Hello everyone. Today we are going to do the application of Similarity Theorem. You can check the previous videos. We're busy proving them. So today we are going to do the application. So maybe without wasting time, we can start by recalling. Recall. So if we're having a triangle ABC, and then we are having that these two triangles and triangle DEF. If we are given that these two triangles are similar, you remember similarity? If these two triangles are similar, what does this mean? It means that the corresponding sides are in proportion, AB and DE. And also, the one which is very, very much important, the way these angles are pegged are equal. The first angle is equal to the first angle of this triangle. This angle B and the angle E, they are equal. C and F are also equal. The way these angles are pegged, they are pegged in a way that they are equal. For example, what I'm trying to say is that angle A, if you can check there, angle A is equal to angle D. And also angle B is equal to angle E. And also angle C is equal to angle F. So before we talk about a diagram, this is the basic that you need to know. You know that all these angles are pegged in this order. So if you prove that these two triangles are similar, and remember the theorem, their sides are in proportion. So it means that side AB, this one, side AB divide by side DE. So meaning that here we're going to have our DE. And then also you can check BC, the same format, BC, this side. Therefore it means that that side it will be EF. And then lastly, BC, you see this one, BC over EF. BC over EF. These are the things that you need to know when we deal with application. Know how to prove angles, you know how to apply the proportionality. So let's go to the first example. I prepared a question for you. This is the first example we are having. If you can read here, in the diagram below, ST is a tangent to the circle at T. WT is a diameter of the circle with center O. Double K is parallel to VT. And then PK, VRST are drawn, and KE is equal to PE. So these are the information that are going to assist us as we are going to be working here. So when you study the diagram, before you attempt to answer any question, study the diagram. You see that you're having your diameter there, you're having your tangent there. So you study this diagram before you attack any question. All right, let's go to the first question. Give a reason why W2 is equal to T4. You have to go and check where are we having our our what? W2, angle W2 and angle T4. These are the two angles. On our diagram, W2 is here, and then T4 somewhere here. And remember that this one is a what? It's a tangent. And then this angle there, W2, something must be fixing there, because we know that whenever we hear that there is a tangent, we have to look for something like tan chord, because a tangent, it just reminds us about the angle between a tangent and a chord is equal to that. You see, this is a tangent, and also this is a chord. That means angle between a tangent and a chord is this one. So this angle is equal to the angle which is subtended by, you see this one, subtended by this chord, which is W2. So meaning that when we deal with our solution, let me get a paper so that we can go question by question. So the first question, we are on solution here. Number one, W2 is equal to T4. y double 2 is equal to T4. I already shown you that this angle here and this one are equal. So these ones are equal, sorry. Then we are going to write the reason, which is what? Tan chord. The reason is tan chord. Then we go to the second question. I'm showing you how to answer these questions. So write down with reasons two angles which are equal to 90 degrees. Remember, from the paragraph up there where you were reading, there is a word diameter. You know, angle subtended by diameter is 90 degrees. So that means this one is a diameter. So class, as I'm showing you here, whenever you hear about the word diameter, just know that there is an angle that it subtend, which is what? 90 degrees. And another angle, which is 90 degrees, it is formed between perpendicular what? Lines. Lines that are perpendicular, they form 90 degrees. They intersect at 90 degrees. And it can happen with our radius and our tangent. Every time radius and tangent, they form 90 degrees. Okay, let's go back to our question. Look here. 90 degrees, which one can be equal to 90 degrees? This is our diameter. So this diameter here, you see this one, diameter, it subtend this angle. So it means that WKT is equal to what? 90 degrees. Why is it equal to 90 degrees? This is an angle subtended by diameter. An angle subtended by diameter, others they say angle on the semicircle, is still correct. So this one is 90 degrees. What is the other one that I was telling you about? Remember, this is a diameter, OT, it's a radius. And then we're having this line here, ST. So it means that this line is perpendicular to this because radius and tangent are perpendicular. So meaning that a T1 plus T2 is equal to 90 degrees. T1 plus T2 is equal to 90 degrees. What is the reason? Radius perpendicular to what? To tangent. Radius perpendicular to the tangent. That is the answer for 1.2. I hope you are still following. You can check the diagram again. So let's go to 1.3. Let me just put this so that you can be able to see it properly. We are trying to answer now 1.3. Prove with reasons that triangle WKE. Therefore, I'll use my red pen here to show that which angle is WKE. So this is I'm going to come to my diagram and try to show you. So you can see this is the triangle that I marked. Okay, I go to another one, PTE. PTE. You can see that is on the black. So we want to prove that this triangle and this one are similar. How do we prove similarity? We can either be proving it by proportion sides or by equiangular. So let's proceed here. We are on 1.3.1. So remember, I told you A double K E similar to triangle PTE. These are 5 marks for free. You can see this question, 5 marks for free, because the way these letters are pegged, they are pegged in a way that they are equal. Before you even do anything, you know what you want to solve. We look at WKE. That means you are dealing with W2. On this triangle, you're having angle W2. So you want this angle to be equal to this P. PTE, which P? It's P2. So you are going to write your P2 here. You want these angles to be equal. I'm going to leave a space for the reasons there. I'll go and look at the diagram and see why are they equal. Therefore, K here is K2. You see, I'm having my K2 there. And then on this PTE, we are having T what? T2. So these are the angles. And then now we're having W what? E1. E1 with E3, E1 with E3. Don't be tempted and say common because there is E here. Just look at on the diagram, it's E1 and E3. So don't say common. So like I said, these are free marks. Now you know that W2 and P2 are equal. Just go and look for a reason on the diagram. Let's check why W2 and P2 are equal. You can see that angles subtended by the same arc. This is the same segment. You see, angle on the same what? Same seg. Angle on the same segment are equal. You see, this is so easy. Now K2 and T2. Where is K2? It's here, and T2. The same issues. This is the same issue. Same what? Segment. You see. And when you are proving similarity, if you prove two triangles, then you find out that they are the same. That other one, if you do not get the reason, you just write third angle. But in this case, we know that these are what? Vert-op angles. These are vert-op angles. So after doing this, you come to the what? Conclusion. Triangle WKE. It's similar to triangle PTE. Why are they similar? What did you prove? You proved that these are equiangular triangle. I hope we are still together there. Now, we're going to the question 1.3.2. This is the question that we are having, 1.3.2. Let me try to create a space again as we are trying to answer this one. Class, what you must know, look at the marks. Look at this. This question is a follow-up of this one. Remember, you already proved that this one are similar. Therefore, their corresponding sides are in proportion. So 1.3.2, you can see here on this triangle, this is the triangle WKE, similar to triangle PTE. Now, I said the corresponding sides are in proportion. This one, WK over PT. WK over PT is equal to WE, like we said, WE over PE is equal to KE over TE. Then you give us a reason. Why are you writing this? Why are you writing this? It's because this triangle is what? Equiangular. You can just write equiangular triangle. You see? Equiangular triangle. So that means this is equiangular or angle. Now, when you check in your question, you're going to check the things that you are having. TE is part and this one is there. Therefore, I'm going to get rid of this one. So I'm going to take this one and say WE, multiply by this, it will give me my TE, and this one, it will be PE, multiply by what? By KE. All right. But when you look at this one, you have to recall up there the information that you are given there. You see there. What are they saying here? KE is equal to what? PE. KE is equal to PE. Where there is, check the answer, it's in terms of KE. Where there is PE, I'm going to write KE. So it means that I'll write KE multiplied by KE is equal to WE multiplied by what? TE. You see? So KE times KE, what do you get? KE times KE, it's KE squared. Is equal to what? TE multiplied by WE. You see? This is how we prove these similarity problems. This is how you have to just work them out like that. So let's go to the last question. This is the last question. This is so challenging and it's a very good question. What we're going to look at, we want to prove a proportion. You see? So before you attack this question, you look at the marks. So these marks, they show you that you have to first get two triangles that are similar. Then you show that their corresponding sides are in proportion. So 1.3.3. What do we do? Let's go and check it on the diagram. We're having side KE. You see, this is side KE, and we are having VT. This is VT. We are having double R. This is double R. You can see this is double R up there. And then VR. You can see VR. So these things, they are showing you that this VT and this side, they are showing that there are two triangles that we're going to look for. These are VRT, because you can see even in your proportion, you're having VRT to show that this big triangle is included. You see, and we also have double K. So this double K, they are showing that you are looking at these two triangles, this one and this small one. Okay, suppose we want to prove that these two triangles are similar. Look at this R, this R1 is found on this bigger triangle. Okay, or let's make it simple like this. In triangle RVT and triangle RWK, we want to look at these two triangles. Let's first check the sides that are the angles that are equal. So look at this one. In this first triangle, we're having R1. R1 is found in this RVT, and it's also found in this one. That's why you are going to come and say, even on that other side, there is R1. In another words, we are going to say R1 is what? Is common. R1 is equal to R1, though we just have to write R1 is common. Now, remember I told you the way these letters are pegged. Look at V and W. V and W. So we're going to come here and write V and W1. So why V and W1 are equal? You can see these lines are parallel. So it means that here we are dealing with what? Corresponding what? Angles. These are corresponding angles. Then you proved the two what? Two angles. Then what about the last one? It's T. You see, this is T2, angle T2 plus angle T3 is equal to what? K1. So what is that? Again, it's corresponding what? Angles. So therefore, what does it mean? It means that triangle RVT, it's similar to triangle RWK. These are similar because you proved that all the angles are what? Are equal. The corresponding angles are equal. So after proving this, you have a liberty now to use what? Proportion. You see? So we're going to come and say RV over WR is equal to RT over RK, and is equal to VT over double K. Therefore, you are going to look at the question. Your question is having double K. You see, double K over VT. You see, this is what is happening. Double K over VT, and then double R over VR. You see, double R over VR. Though this part is this portion is not here in our required to prove. So I'm going to copy this one here. I'm going to come here and say VR divided by WR is equal to VT over double K. Then I cross multiply. I'm going to get VR multiplied by double K is equal to double R multiplied by VT. Then, because I want my denominators to be VT and VR, therefore I'm going to divide everything by VT multiplied by VR VT multiplied by VR. Then VR will cancel, you see? They will give us a 1. So that's why this side I will have my double K over VT. And then this side I'm going to have what? This one will give us a 1. I'm going to have WR over VR. That's it. So you see this question. This is what it needs you to do. Every time when you get a question, analyze the diagram. And remember that similarity, it's a follow-up question. When you prove that two triangles are similar, therefore, that other one, we are going to deal with a proportion. So thank you so much. I hope you enjoyed. Go and practice and get more questions from previous question papers, and then you're going to be better as time goes on. Thank you so much.